What's up? It's your man Jimmy Chan. All right, let's talk about LabWork 10 answer key here. So on the first one, we had to basically select an equation that would represent this graph. So one of the things I did was basically I knew, or what you need to know, is what an exponential graph actually looks like. So if I have f of x to any of any base raised to the x power, the curve actually looks this way, where starting, it's going from left to right, it's going from very close to zero, and then it sweeps up. More importantly, it always crosses the point 0, 1. Okay, so that's the main part. Now, if you look over here, it crosses the point 0, 1 as well. So that means there's no shift up or down. Okay, the difference between these two graphs is the fact that it reflected over the y-axis. Okay. Ooh, excuse me. All right. Now, if you look at this graph closely, you will see that when x is equal to -1, is actually 3. So you have this point here, -1, comma 3. Okay? So if it was to reflect over the y-axis, over here you should have a point that is 1, 3. Okay, which it is. Now, this is the reason why I knew that the base of this graph is f of x is equal to 3 to the x. And you're like, how would we know that, right? Yeah, and you're right. How would we know that? Well, let's take a look. If I took this and let's say I make a table of this, okay, and here's my x and here's my y, right? So if I plug in 0 in for x, I'll have 3 to the 0 power. 3 to the 0 power is 1. If I use 1, 3 to the first power is just 3. So I will have the points 0, 1 and 1, 3. That would be my original graph here, which makes sense. Look at that, 1, 3. Okay, so that's the reason why I knew that the equation is f of x is equal to 3 to the x. Well, if it flipped over the y-axis, what value changed? Did the x change or did the y change? Okay, and how does it change? Well, the x value changed. So if you look at the original, which was 1, 3, and it went to -1, 3, only the x value changed. The y value stayed exactly the same. So now I know that my so-called transformed graph, let's call it g of x, that's going to equal to 3 to the -x. Okay, because the x value changed, so it's only going to affect the x value. All right, so with that being said, that is going to be my choice D. So that will be my answer. There we go. And there we go. All right. All right, so again, so 0, 1, it's always going to cross 0, 1, okay, the original. And then because of the 1, 3, I knew it was going to be a base of 3 because 3 to the first power would be 3. So that's the reason why I knew that. But because the x value switched from positive to negative, that means it's affecting my x value. So that's the reason why I negated the x value there. Okay? All right. So on to number 2. All right, number 2. So this tells me that a population is growing at the rate of 1.7%. Okay, And in 1999, it started out with 7,638,000 people, and wants to know what the population is going to be in 2004. All right. And they even gives you that equation of f of x is equal to y naught e or times e raised to the power of 0.017 t. All right, so the question is, what's that 0.017? Well, that is the decimal value for 1.7%. So let me do it this way. If I had a decimal and I want to change it to a percent, what I would do is I would take, well, let's use this example, 0.017, and what I would do is move it 2 places to the right, just like this arrow, okay? So I would get 1.7%. But if I wanted to, and again, the D and the P is in alphabetical order. That's why I put the D on the left, the P on the right. Now, if I want to go from percent to decimal, like a 1.7% to a decimal, what I would do is, notice that the arrow is pointed to the left to the decimal. I would move the decimal point to the left twice. So there's my new decimal, and I need a placeholder there. So my decimal will be 0.017 or 0.017. All right. So remember that I always want to switch this to be a decimal. Okay. So this is the nice part about watching the video, because you see these explanations here. All right. So let's talk about this equation that's given to me. That's why I wrote it twice. All right. So let's say that I'm talking about the t here. Ooh, look at that. That looks nice. Okay, so the t here is time. And time is typically in years. Okay, next one. Nice. Except I need it to come down a little bit more. There we go. So this one here is my rate, which I typically want it in decimal. Okay. The E is going to be E. It's right on your calculator. That's what you're going to use. And then here, Y sub 0, which we really call a Y naught, right? As in, this is the initial amount. Okay, in this case, what the population was in 1999, okay? And then here, the f of x is also known as just plain old y, which is known as your final amount. Meaning, if I can spell them out, it'd be great. Okay, it's a final amount. So in other words, what is the population in 2004? Okay. So, with that being said, one of the things that so the rate is already put on there. The initial amount I know. The final amount is what I'm looking for. The only thing is that I need the time. So if you look at the time, how many years is from 1999 to 2004? Well, that is going to be 5 years. Okay, so that means 5 years is my time. All right, so let's go ahead and find this. So I have my final amount, let's call it y, is equal to my initial amount, which is 7,638,000, times e raised to the power of 0.017 times 5 years, which is the T. Okay, so all you gotta do is plug that into your calculator, and when you plug that into your calculator, you're gonna get 8,315,620.955. Boy, 0.955 is a weird person, right? It's not quite complete. It's not all there, right? But notice that it says to round to the nearest 10,000. All right, so rounding to the nearest 10,000, I'm looking at this digit right here. Oops. Okay, and that digit right there is what I want to look at, so I need to look at my 5. Okay, I gotta look at the 5, and the 5 tells me what? To raise it up, because it's 5 or greater. So with that being said, that means the population in 2004 will be about 8,320,000 people. Okay, and with that being said, we have choice C, and that would be my answer there. All right, there we go. That's number 2. On to number 3. Well, number 3, with investments, you have 2 equations that you do have to remember. One is A, right? The final amount is equal to the principal times 1 plus R divided by N raised to the NT power. And N stands for the number times compounded in a year. Okay, so, and T is the time, which we have is 7 years. The rate is 10%. And again, the 10% has to be changed to 2 decimal places. So 0.1 is my decimal form. And the N is how many times it compounded in 1 year. So semi-annually, right? That means halfway in the year, it gets compounded. And the end of the year, it gets compounded. So the N here is going to equal to 2. Okay? And my investment amount, which is my principal, is $2,000. So because that there is an N here, that means I will use the first investment formula rather than the second. The second, because it's an E, it means that it's compounded continuously. Okay, so you don't really know, it just keeps on going. All right, kind of like our student loans. So we're using the very first one, so it's going to be A, which is the final amount, is equal to P, the principal, times 1 plus R over N raised to the NT power. All right, so that's what I'm looking for, is what the final amount is. So my final amount is A still. My principal, which is my investment, is $2,000 times 1 plus the rate 0.1 over N, which is 2. All raised to the N, which is 2, times T, which is 7. Okay? So really what I have here right now is A is equal to 2,000 times 1 plus 0.05 raised to the 14th power. Okay? Or better yet, how about this? This is 1.05, right? Because 1 plus that 0.05. So let's plug that into their calculator. 2,000 parentheses 1.05 close parentheses caret 14. And that's going to give me an A of, or my final amount of, $3,959.86. Okay, and that's going to be choice D. Boom, there you go. There's number 3. And number 4, same idea. But notice that this is saying continuously. Okay? Because it's continuously, it means that I want to use that formula there, that investment one, right? Because the E represents how it's continuous. All right, so with that being said, so we're going to use A is equal to A, which is the final amount, is equal to the principal, which is the initial amount, times E raised to the R times T. Well, what's my R? Well, it's 7%. So if I move the decimal places twice to the left, or my decimal place twice to the left, it's going to be 0.07. So let's go ahead and put that in. So A is equal to my 6,000 investment times E raised to the R, which is 0.07, times my time, which is 5 years. Okay, so essentially what I have right now is A is equal to 6,000 times E raised to the 0.07 times 5, which is 0.35. Okay, let's plug that into the calculator. So 6,000 times E to the 0.35, or 0.35, and my final amount is going to be $8,514.41, which is choice B. All right, number 4 is B. Yep. All right. There we go. All right, so that's number 4. Number 5. All right, so this one here, so this is the form that you really need to know, right? How to switch from exponential form to logarithmic form and vice versa. So you got to know how to go from exponential form to logarithmic and logarithmic form back to exponential form. And one of the things I keep on reminding students is this, is that notice that the base here with the log is with the x at this time. Well, when you change the exponential form, now the base is now with the y, okay? So that would kind of help you, right? Obviously, from the logarithmic form to the exponential form, the log disappears, and the only difference is that the base gets switched. Instead of with the x, it's going to go with the y. If it starts with a y, then it goes with the x, okay? So in this case, since the base of 5 is right now with the x, right, and not the 3, so when I switch this over, it is going to be x is equal to, now the base 5 is going to be involved with the 3, okay? And that is going to be choice A. I know that you guys are going to have questions on how much work do I need to show on this, and that's essentially all it is, right? There's really not much work to be shown. And if you wanted to, basically take this right here and kind of put it over this thing right here, right? So the B is the 5, the x is still the x, and the 3 is my y. All right, so the 3 is my y, so the 3 will go up here, my base of 5 will be right here, and my x would be right there, okay? So if you look at that, the base to my 3, Okay, so you could do it that way if you guys want to, and then as long as you know this part, that's the biggest issue right there. All right, so that's number 5. So number 6, same idea, except I want to go from exponential form to the logarithmic form. Okay, now here is a little bit different, so I got to do a little bit of work before I actually change it to logarithmic form, because I don't have a power yet. Right, is I have a cube root, but I don't have a power. Well, the cube root, one of the things that we'll be talking about is about the sunshine and about the grass and what grows under the grass, which is roots. The root of 3, cube root. And then what's above the grass is the sun, which is which gives you the power. So the grass is your fraction. Here, why I do it this way. So the way I do it is that here's the sun, right? And here's your grass, right? So if I'm here chilling, right? And this grass is also my fraction, okay? So above the fraction is the sun giving me power. And underneath the grass, I'm going to get roots, right, for the grass. So that's the reason why I have that there. So if you think about it, if I have, well, in this case, I would just use this. I got 8, okay? So what power does 8 have currently? Okay, so that's my grass. What's the power that my 8 has? My 8, my 8, there it is. My 8 has a power of 1. Well, what is the root? Well, the root is also the index, which is the 3. Okay, so 8 to the 1/3 is actually the same as cube root of 8. Okay, so this is now equal to 2. Now I can convert that from exponential form to the logarithmic form. All right, so hopefully you guys will see this picture in class. All right, so with that being said, my base is still my base. The base is 8. Okay, so again, this right here, is my base, right? Okay, so that means my base is now no longer with the 1/3. Okay, now the base is with the 2. So this is going to be 1/3. Oops. Hold on. Now I'm going to have 1/3 is equal to log base 8 of 2. Okay, so notice what I just did, right? So if I take this right here, right? So this base is now, instead of with the 1/3, it comes over with the 2, and then I just do the log. And that's all it is. So now this 1/3 becomes a regular 1/3 rather than a power of 1/3. Okay, so that's exactly what I did there. Undo. There you go. All right, so that, ladies and gentlemen, is choice A. There we go. All right, so that's number 6. Number 7. Okay, so let's look at number 7. So it wants me to graph 2 to the x and to get the g of x, which is 2 raised to the x plus 2 plus 1. So it's more of a transformation. So again, if I take this right here, let's duplicate this, bring it down, and let's make a table. We won't need too many points, pun intended. So here's x and y. So my first point is going to be 0. Come on. Come on. There we go. So 2 to the 0 is what again? To 1. Correct. And then 1, 2 to the first is what? 2. Okay. So I have the point 0, 1. And I have the point 1, 2. Okay. So what is this transformation telling me? So let's go ahead and select this right here. Let's make this blue, and then we will make this one red. Okay, so the plus 2 here means what? The plus 2 means what? It means to shift left twice, right? Remember that the x is kind of like backwards, right, when we did transformations. So if I was to do that, what does it mean to shift left twice? Whoa, that was weird, huh? Okay, so if I had 0, 1, where would that be now? That's going to now be shift left twice, will be -2, 1. And this one here, shift left twice, which is affecting the x, right? Shift left twice, I'm going to have -1, 2. Okay? So what does this tell me then? Oh boy, how do I do this? There we go. Oh. The plus 1 means to shift up 1. Okay, so if I had to shift up 1, what's going to happen? Well, now it's going to be a -2, 2, and -1, 3. Okay, so we look around of which of these choices have -2, 2, and -1, 3. That would be my choice C. That would be my choice C. And there we go. All right, and that's number 7. Number 8, I gotta change this to logarithmic. So, okay, so here's my exponential form, right? Except it's a little bit backwards, right? So I guess if you really wanted some help, you could do it in the same form as this. So let me go ahead and copy this right here, or duplicate it and move it over here. So if you want to, you can make it in the same form. So I could write this as 1/25 is equal to 5 raised to the -2. So you know what the x is, what the base is, and what the y is. And now convert it to this right here. So go ahead and take this and plug it into here. Okay, and you should get, so where's the y is -2, right? And is equal to log base b, which is 5, and the x is 1 over 25. There you go. And that is going to be choice D. So if the other explanations didn't help you, hopefully this one does. All right? And on to number 9. More. Oh, we can use a calculator. Well, good news, bad news. Bad news about your calculator is that you can't do a log base on here, but I will teach you how to make that happen. I believe you can do this on Desmos with a calculator. So what we're going to do, if we're just using an old-fashioned calculator, that we're going to change it to an exponential form first. Okay? So let's say that this is equal to y. So let's go ahead and do this. Copy or duplicate this, bring it down, and we'll just say y equals. So that it is the same form as this right here, right? Except more spread out. There we go. All right. So now I got to put that into, let me bring this over. Oh, that's what I want to do. Duplicate that. So now what I want to do is take this come on. And plug it into here. And what do I get? So if you notice, the y is still the y, right? And the x is the 1/16 is equal to, the base is 4, and the y is the y, okay? So in other words, 4 to what power would give you 1/16, right? So essentially that's the question you have to ask yourself, right? If I say 4 to the first power is going to give you 4. 4 to the second power is going to give you 16, but this is 1 over 16. Ooh, it means the 16 doesn't like being on top, right? So that's why I went to the bottom. So doesn't that tell me that y is equal to -2, since 4 to the -2 would mean 1 over 4 squared, which would be 1 over 16. Right? So, with that being said, then I have choice D. Another advantage of watching the video. There we go. That's number 9. Nice. On to number 10. So 10 wants you to graph this logarithmic function, okay, or determine the equation for this logarithmic function. All right, so log of any base function is going to give you still this point right here, okay? So a log function is actually the inverse of the exponential function, okay? And you're like, well, what does it mean by inverse? Well, remember, inverse means that you're switching the x and the y, okay? It's the flip-flopping of the x and y. So the exponential function, we said, crosses 0, 1. Well, if you flip the x and y, now what do you get? 1, 0, right? So that's why you have that. Now the question is, what happens? So if you come over here, 1, 0 would be right. 1, 0 would be literally right here. This would be 1, 0. Well, how did that move? How did that shift? Well, it shifted right. 1 unit, right? Or 1 unit, right? It shifted 1 unit to the right, okay? So since it shifted 1 unit, and notice that the graph looks pretty much the same. It didn't flip over the x-axis or the y-axis. It just shifted to the right one. All right, so if it shifted to the right one, that means it affected the x value, right? So if it shifted since it affects the x value, now with the x value, things are kind of backwards, right? So that tells me that this is a log base 4, so that means my f of x is going to be a log base 4 of x minus 1 because it shifted to the right ones. All right, so with that being said, it's going to be choice C. There you go. Dang it, undo. Go. And there it is. So there is my answer key for LabWork 10. If you have any questions, let me know. Later. Bye.